We're still solving here for number 6, so remember your end goal is to get x equals a number. Also, when we're solving, we want to get rid of fractions, so that's kind of what we need to work towards. We do need to state our domain restrictions. We do this by setting our denominators equal to 0. So x plus 1 cannot equal 0. Therefore, x could not be a negative 1. Now, if you do this before you factor, you may also be setting up 3x plus 3 cannot equal 0. But when you do your math, you still end up with x cannot equal negative 1. So you really only have one domain restriction here. Okay, now we do want to factor everything. The only thing left to be factored is our denominator here. We can factor out a 3, and we're left with x plus 1. So our LCD in this case, least common denominator, we have to include an x plus 1. When I look at that second fraction, I also need to include a 3. Then when I look at my third fraction, the 3x plus 1 is already included. So we're going to take our least common denominator and multiply our numerators times that. Okay, notice we haven't actually done any multiplication yet, because remember, our end goal is to eliminate our fractions. In order to eliminate, we are canceling out factors. So if I were to multiply this out, I would have to go backwards and factor again. So I'd be doing extra math. So my x plus 1's cancel in my first fraction. My 3's will cancel in my next fraction. And then on the other side of the equal sign, my 3's cancel, and my x plus 1's cancel. So at this point, 3 times 3 is 9, plus, we have x plus 1 times x minus 2. This is set equal to 13. If you need any extra help on setting up this problem or why we multiply, you can go back and look at the video for 5. But now I have no more denominators, no more fractions. So all I have to do is simply solve. I can't combine anything yet. I have to get rid of these parentheses first, so we will FOIL this out. So I have 9 plus x times x is x squared. X times negative 2 is negative 2x. 1 times x is x. And then 1 times negative 2 is negative 2. Okay, now we can combine our like terms. My 9 and negative 2 makes 7. I only have a single x squared term, but I have a negative 2x plus an x, so that gives me negative x equals 13. At this point, I notice I have an x squared term and a single x term, so this is a quadratic I'm going to have to solve. So first of all, if I'm solving a quadratic, I do want it in standard form. So I'm going to rewrite this with my x squared term first, then my single x term, and then my constant 7. Now, anytime you're solving a quadratic, remember you have to set it equal to 0. So we will move the 13. We get x squared minus x minus 6 equals 0. At this point, you can use quadratic formula, which would be a longer way to solve this, but you can also factor. Factoring will be our quickest method. So when I factor this and set it equal to 0, you get x minus 3, x plus 2. Two things multiplying to give me 0. I can set each of them individually equal to 0. So I solve, and x equals 3. And I get x equals negative 2. is double check with our restriction, and the only thing x can't be is a -1. So both of these solutions should work, but I do want to check them in my original equation. So we'll start by checking our x equals 3. So we have 3 divided by 3 plus 1 plus 3 minus 2 over 3 equals 13 over 3 times 3 plus 3. This simplifies to 3/4 plus 1/3 equals 13 over 3 times 3 is 9 plus 3 is 12. You do have to do a little bit of work with fractions here. We need a common denominator, which would be 12, so I multiply this times 3 over 3, and this fraction times 4 over 4. So we get 9/12 plus 4/12 equals 13/12. That is true, this solution works. Do the same thing with our -2. Our original was 3 over x plus 1 plus x minus 2 equals 13 over 3 times x, which is 3 times -2, plus 3. And I'm running out of room here, plus 3. Okay, so 3 over -2 plus 1 is a -1, plus -4/3 equals 13 over 3 times -2 is a -6, plus 3 is a -3. So we get -3 over 1, we're adding to 4/3, so we need a common denominator. All we have to do is multiply this side times 3 over 3. So we get 9 over -3 plus a -4/3 equals -13 over 3. And -9 and -4 would make a -13 over 3. So this one also works.